Unite beyond boundaries. Innovate together. Joe's PANKRATION 2024. No border.
Please go ahead.
Hello, everyone. Today, I'll be talking on the topic of cloudy with a chance of precision, where I'll be basically discussing about how we can deploy weather forecasting apps on AWS EKS. I'm Neetu Mallan. I'm a manager of DevOps at EasyOps Technologies. I'm an AWS community builder, and I love speaking and blogging about AWS services and their use cases. So the agenda for today's this topic is, first of all, I'll give an introduction of how I have taken up an application and Dockerized it. So what kind of best practices and cloud native specs I've followed, how I build the Docker file. Then I'll move on to an overview of the AWS services that I've used in order to get this application working in EKS. And finally, I'll talk about the application architecture. I'll give like a demo of how I have deployed this application. And finally, we'll conclude the session. So in the sense of the introduction, basically, this is a weather forecasting app that I've taken from, this has not been developed by me. It has been developed by someone, and I got it from GitHub. But I'll just share that. So let me go on to, sorry. Yeah. So let me go on to, yeah. So this is the GitHub repository, and this is a Python application. So I was looking for an application that I could put onto AWS EKS, and I'm thankful to the developer. This was developed a year ago. So I had to take it up and do some changes with respect to the version that was being used. But rest of the code is the same. And this has been created with Python and Streamlit, and it's using the Open Weather Map API. So once I deploy it, I can show it to you what, like on EKS, how it is working. But basically, the idea is that we'll take a city and we'll select either the temperature unit of Celsius and or Fahrenheit, and we'll set the graph type, whether it is bar or line graph, and you'll get this kind of a summary: what is the temperature and what's the humidity, pressure, visibility, the 5-day min max temperature, and also humidity index. So this is what it would look like. But right now, what I had is basically the Python application. Now let's go on to the next topic. Let me move on to my presentation again. All right. So how I have containerized this application. So I had a raw Python application and I had to Dockerize it. Now going back to my Visual Studio Code, let me go to, yes. So this is a Docker file. So what I've done is I have used the cloud native best practice of having multi-stage builds. So I have this Python, I've taken this Python Slim Bookworm base image, and on top of that, I have built this application. Built the entire image of the application. So this is my base image, and on top of that, I have created a work directory. So a cloud native like best practices actually to create a work directory rather than directly working on the root directory of the base image, right? So we create a work directory and put our files there, our application files there. Then I've done an apt-get upgrade, and I've created a virtual environment. I've copied my requirements.txt. So if I show you the requirements.txt, it has all these dependencies or modules that we have to download. So I'll pip install this and on this base image and get all the compiled binaries in one place in the virtual environment. Finally, I'll have the builder image, which is going to be the actual image where my application is going to work. So this is also a Slim Bookworm image, and according to the open containers image specification, it's always a good practice to give a label. So though the image has been created by me from scratch, the application code is from someone else. So that's why I have mentioned this GitHub repo to give due credit to the developer. And then I copy from the base, I copy the virtual environment here, and I copy my weather app application as well. Finally, I'll create a user that is different from the root user. the best practice or the security best practice in case of an image is to always run it as a container with a non-root user. Okay, so we should not use the root user because it always has elevated privileges. So I'm creating a user called Jim here. I'm exposing this port 8501 because that's where our Streamlit application normally runs. And the entry point is actually to run to the stream. We use the command streamlit run and the application file name. So in this case, this is the entry point, and we have given this command. So when I started working on this application, creating the image, when I was not using a multi-stage build, the image size was around 900 MB. But now, if I've checked here, and the size is down to 587, it's totally due to the fact that I've used multi-stage builds. Now let's go back to my presentation. So now I have this image that I've created, right? Now what? Now next part is to move it to AWS. So how do I do that? Which services am I going to use? First of all, I need to host this image somewhere. So I'll be using ECR, which is the container repository in AWS. It can help us to host all our container images because my app, say any application we create, it might be widely adopted any day. So better to create it on multi-architecture, multiple architectures like AMD 64, ARM 64. So ECR can help us to store these multi-architecture images, and it can also allow us to share and download images over HTTPS. Next is the secrets manager. So basically like a vault, as you can see on the right side, it's basically going to store my API key. So to talk to Open Weather Map API, I will need an API key. I've created that, but I cannot embed it into my application because that's basically hard coding, which is not a good security practice. And that's why I'll use Secrets Manager. The advantage with Secret Manager is that it provides you strong encryption. It allows you to rotate your secrets. So you're, not only API keys, you can store DB credentials, application credentials, authentication tokens. You can name it, any secret that you want to store. And then you can access it programmatically. And in my case, I'm also storing it in as a Kubernetes secret. I'll show that in my demo. Then next is like EKS. EKS is the Elastic Kubernetes Service. It allows us to harness the power of container orchestration in AWS. So you can see like Thor uses his hammer. EKS is also our tool which we can use to harness the use of Kubernetes. And EKS allows us to as it automatically manages the Kubernetes control plane nodes, so we do not have to take the headache of managing it. We only have to look after the worker nodes where our applications will run, and they can run on either EC2 or Fargate based nodes. Then the load balancer. So load balancer basically allows us to access the application. Now I'm running it in Kubernetes or EKS, but how do I access this application, right? I'll create a service to access it, and that service, it will be a load balancer service, which in turn will create a classic load balancer resource in AWS. I'll show that as well. And that will give me high availability and automated scaling and let me connect it over the internet. Right, so let's go next to the application architecture. So let me show like what the application architecture would look like. So I have this Python application. It is Dockerized using Docker. Then I'm uploading it into ECR and downloading it and orchestrating it in EKS. Now I have to read the API key. What do I use? I use the secret store CSI driver. And that driver in turn talks to the Amazon Secrets config provider, which assumes a role and reads the secret from the secrets manager. Then finally, the application is viewable in AWS load balancer. And I can, because of the flaky network at my end, I'm not going to be able to access it on the browser directly because it gives a WebSocket timeout. So I would rather access it from the Windows machine. So because the network would be better there. So next. Okay, so let's do the hands-on on this. Like I already have things running to save time, but I'll go over what I have done. So let me go to Visual Studio Code first. And before that, just let me go to the ECR. So I have this repository, right, which I've created specifically for this demo. And if you see, there are images here. So there are two images. So I have pushed one AMD 64 and an ARM 64 image. And there's an image index. So what is this basically? So in Docker Hub, what we do is basically Docker Hub is also a similar repository, but what we do is we push both these architectures together. In AWS, it's a bit ECR, it's a bit different. You push these together. Okay, I have pushed both of them using Docker buildx, but I have to create a manifest. Manifest basically tells ECR that it is the same image, but it's for two different architectures. So I will build using Docker buildx. I'll build it. Docker manifest, I'll create these two. Just a second, let me hide this panel. Right, yeah. So yeah, it will then create this manifest file. And if I inspect this manifest, you can see it here that there are two architectures. That is, one is AMD 64, another is an ARM 64, right? And SHA, if you compare, it will be similar to what has been loaded into AWS ECR. And finally, we push it. So that's what we can see it here. There's an image index and there are two images, right? Then let me go to my deployment file. So this application is already deployed. First, let me quickly show the deployment. So there is the deployment that we can see here. Then we have a service, load balancer service, which is present here, right? And we have a pod which is running. In the pod, if I check, like this is my deployment file. So in the deployment file, I am using this image, the ARM 64 image, right? I'm using it. I am downloading that image. I am using the port 8501. And I have a volume mount, basically, to mount API secrets. What this is doing is embedding the API key from the secret. So if I show the secret here, where is the secret? Yeah. So this is the secret I've created for my API key. And I need to get that into Kubernetes. For that, I have used this volume. Okay, so this is the volume mount. This is a volume. This is the service account that it is using. And this volume mount will have this API secret at this place. So mount API secrets, this location. I have just exec into this container, and using just ls-la, I can see that this API key is present here, right? So that has been, in turn, it has been given as an environment variable to this container as well. So from using, if I show my application, it's using os.environment variable, it will get the API key. So this is the thing. And let's take the service external IP and just hit the URL and check. Okay, so this is my RDP. I'm basically RDPing into a Windows machine on AWS. So let me do http:/command V 8. So see, the application is ready. Now let's take any city. Say I want to look for Tokyo. What is the temperature currently? So I can go to Celsius, or I can select Fahrenheit. Then I can take the bar graph or line graph and see. I can see that what is the temperature currently? How is the wind speed, the humidity, right? What it's going to be like, the 5-day min max, the sunrise sunset times, and the humidity index. So this is how powerful EKS is. Like, I have taken an application which is open source, right? It's on GitHub, and I am able to run it in, containerize and then run it in EKS. We can go for some other, like, let's go to
just 1 minute.
So yeah, this is what the line graph looks like. So yeah, this is what I wanted to show with my demo and my application, like how we can harness the power of containers and EKS, and how it can be, we can develop all this and make it running in AWS. So yeah, I would like to conclude my session. Thank you.